Most of human history has been spent finding out about animal diseases the hard way, via loss. A herder wakes up to find that his sheep's joints are swollen and they are having trouble breathing, or a farmer finds that his chickens have stopped laying eggs. These two people are both in the same boat. When these symptoms show up, it's likely that infections have been silently spreading from one animal to another for weeks, and they may have even gotten into people. In the late 1800s, illnesses like rinderpest killed a lot of animals, but they also caused food systems to break down, communities to move, and whole regions to change. Even though we live in a modern age, the foot and mouth disease outbreak in the UK in 2001 killed approximately 6 million animals and cost the economy billions of dollars. Would the outcomes of such disasters have been altered if someone or something had been able to detect them coming before the first cough or fever? People think that artificial intelligence will be able to provide us with this kind of foresight in the future. Artificial intelligence works best when it gets a steady stream of data. This is different from traditional surveillance systems, which rely on manual inspections or reports that are sent out on a regular basis. Every day, weather satellites send information about the weather, GPS collars let farmers know where wild herds are, veterinary labs send diagnostic findings, and farmers use mobile apps to send information about feed, weight, and milk production. All of these things happen at the same time. The data stream has more than just drone footage and infrared images. It also includes information from online marketplaces about the prices of cattle. As a result, an ever-expanding global nervous system has been built, with AI acting as the brain, finding patterns, predicting threats, and giving recommendations. Could the next significant defense against pandemics not be a new therapy or vaccination, but an algorithm that is running in the background? Even though they are complicated, the mechanisms are really interesting. To find out what combinations of environmental, behavioral, and biological indications tend to happen before certain outbreaks, researchers train artificial intelligence models using data from past outbreaks. These could be climate abnormalities, like a wet season that is warmer than usual and causes mosquito blooms, or trade data that shows unexpected surges in the number of cattle being moved between high-risk areas. The models also have the ability to find anomalies. For instance, if a herd that is typically active suddenly stops moving about a lot, or if the milk output in an area drops by only a few % for several days in a row, the AI will let you know. When looked at one at a time, these changes might not be big enough to worry people. But when looked at all together, they might send a strong digital signal that something is wrong. How many early warning signs have we missed over the years because they were spread out over too many people and too far away? Technology is already saving lives. Artificial intelligence helped create a platform called EMPRES-i that combines information about climate, livestock, and vector populations to predict the risk of Rift Valley fever in East Africa. When the algorithm predicts that an outbreak is likely to happen, governments can plan vaccination campaigns weeks in advance. This often keeps the disease from spreading at all. Artificial intelligence has been used in Queensland, Australia, to watch the activity of fruit bats and environmental factors in order to predict Hendra virus outbreaks in horses. This has led to changes in the timing of vaccinations and limited horse-human contact in high-risk areas. In the US, machine learning has been used to keep an eye on chronic wasting disease in deer. This monitoring includes finding trends in how animals migrate and where infections are spreading before the disease gets too big. If these devices were linked up all over the planet, could they make an invisible wall that keeps both livestock and wildlife safe? AI might also be utilized to help protect wildlife. The AI system looks at thousands of hours of video from camera traps in Central Africa, where great apes can get respiratory infections from people. This technology can even tell the tiniest changes in the degree of activity or the makeup of a group. These indicators could mean that someone is sick early on, which lets doctors treat them before the sickness spreads to other people. We utilize artificial intelligence to track the movement of marine mammals along the shore by looking at sonar and hydrophone recordings. This helps the AI guess when marine mammals might get to places where there are dangerous algal blooms. Artificial intelligence might not only protect people's jobs, but it might also help keep biodiversity alive. The results are shocking. AI disease prediction has a lot of potential, but right now it has to deal with a lot of problems. In many rural areas, there isn't enough technology to let people share data in real time, which makes the system have blind spots. Because of political concerns, the publishing of epidemic projections can be delayed or even stopped completely. For instance, what would happen if an anticipated outbreak in livestock put international trade at risk? There is also the problem of explainability. If an AI says there is a high danger of an outbreak but doesn't give a clear and understandable reason for it, would farmers and politicians trust it enough to do something? Is it smart for them to trust a black box that could save lives? Or does blind trust leave the door open for mistakes that could hurt people? You should also think about false alarms as a possible danger. If the weather changes in an unanticipated way, it could mimic the conditions of an outbreak, which would make the AI send out false alarms that would lead to unnecessary quarantines or culling. Farmers' faith is shaken with each false alarm, and in a world when margins are tight, no farmer can afford to have their business interrupted over and over again. Researchers are trying to combine the speed of AI with the knowledge of humans by building hybrid systems where data scientists, veterinarians, ecologists, and local farmers all work together to make sense of predictions. Is it feasible that this is the key to making AI a reliable partner instead of an unchallenged authority? Even so, the momentum can't be disputed. Picture a World Health dashboard that gets its data from a network of sensors and satellites that are all connected. This dashboard could keep an eye on penguins in Antarctica, herds in the Mongolian steppe, cattle ranches in Brazil, and coral reefs in the Pacific all at the same time. It is feasible that notifications might be sent across borders to get neighboring countries ready in case a signal comes in that a tick-borne disease is likely to spread in a certain area. If an AI model finds a change in bat migration that could spread infections to cities, the people in charge of public health might take steps to stop the spread before the first person gets sick. Could this century be the one when people finally stop fighting outbreaks and start stopping them? We are about to enter a new era in the realm of animal health. Artificial intelligence won't replace veterinarians, farmers, or conservationists. Instead, it will help them reach more people and provide them the tools they need to deal with hazards that aren't yet clear. But technology alone is not enough. For artificial intelligence to work to stop disease, we need to be willing to share information across political and economic lines, embrace research even when it tells us things that hurt, and act before the threat feels real. Will we pay heed to the quiet signal coming from a machine when the next silent outbreak happens anyplace in the world? And if we do, will we be able to act quickly enough to stop another catastrophe from happening? Thanks for watching. Don't forget to like and subscribe to our YouTube channel.